Hello and welcome to the guide on how to complete a Unit 1 past paper. In the classroom I provided you with a paper for November 2014 and that's the paper I'm going to show you how to go through right now. If there's a specific question you'd like answering, then please use the YouTube shortcuts that are below the title in the area down here. You're going to be taking the AQA Exam Board Mathematics Foundation level course, and this is a Unit 1 paper. The Unit 1 papers are usually 1 hour, and the most important thing for you is that you can and should use a calculator. Underneath the time allowed of 1 hour, you have the instructions and information and advice on how to take the exam. Using a black pen goes without saying, but it's really important in this exam that you draw diagrams in pencil. As you've seen in the classroom, it's very easy to make mistakes with scales, with what you're drawing, without leaving gaps on bar charts and so on. So it's essential that you get used to drawing diagrams in pencil. The other main pieces of advice are that you should answer all questions. You can't afford to lose any marks on this paper. If you go down to the information, it shows you there are 54 marks in this exam. With an 80% pass mark, you really can't afford to lose that many marks. And finally, the advice at the bottom shows in all calculations show clearly how you work out your answer. It's not like Unit 2 without the calculator where you have to show specifically how you get your answers. Here you need to show them that what you're putting in the calculator. So 3.2 times 4 goes into your calculator, and whatever your calculator displays, then that's what you put down as your answer. You don't have to show your manual working out like you do in Unit 2. Okay, let's start the exam. Question 1. 10 cards have letters written on them. Now, as you can see, the first question, question 1A, says that one card is chosen at random. Circle the chance of Q being chosen. Well, we have 10 cards in total. Therefore, whatever we pick, our probability is going to be over 10. So there's only one Q. So the probability of picking a Q is 1 over 10. Now on your probability scale of 0, which is impossible at the left hand end, and 1, which is certain at the right hand end, 1/10 would be over here somewhere. So it's expecting you to circle the word unlikely. In 1B, they want you to circle the chance of choosing B. Well, on our 10 cards, there is no B, so it's impossible. Circle impossible. Question 1C asks us to draw a cross on the scale below to show the probability of choosing an A. Well, there are 4 A's, so there are 4 cards with A on, out of a total of 10 cards. So 4 over 10. Now when you look at the scale, it's quite nicely divided into 10 sections, with 0.5 being in the centre. So 4 over 10, taking you back to week 2, is 0.4 as a decimal. That's what 0.4 means. So what we need to do is mark on here a cross on 0.4. The next question, what is the probability of not choosing an A? Well, this is going back to your understanding on probability that something not happening is 1 minus the probability of it happening. So if the probability of choosing an A is 4 over 10, then the probability of not choosing an A is 6 over 10, whatever's remaining. Now, as a fraction, this can be simplified to 3 over 5. Our answer on our answer line, as always, is 3/5. Question 2. Adam saved these amounts. Work out the range. Well, in data statistics, the range is the highest value, take away the lowest value. So looking across our data, you have to recognise that 124 is our highest value. Our lowest value is £79.50. Now, this is a perfect example where in the exam you don't try and do things in your head. Do exactly as I'm doing now, put it into a calculator so that you get the correct amount. And the correct amount is £44.50. Matthew saved half as much as Adam. Work out the total amount that Matthew saved. Here you need to add all of the amounts that are given above and then divide by 2. So Adam saved 124 plus £79.50 plus 122.50 plus £96 plus £85. Now again, don't take any chances and put all of this into the calculator. When you put this into the calculator, you end up with £507, the total that Adam saved. So Matthew saved half of that, 507, and we divide it by 2. Again, take no chances. Put it in your calculator and you end up with £253.50, which again you must write on your answer line. Question 3. A band played 20 concerts in 5 continents. They then give you a tally of those 20 concerts. So the first thing I would do is actually add up the tally and give the frequencies to do with each of the continents. So Africa has 1, Asia has 1, Europe has 10, North America has 3, and South America has 5. And just quickly glance over them and make sure they add up to 20. Question 3a asks us to draw a fully labelled bar chart to show this information, and it's worth a whole 4 marks, so there are lots of things to think about. From our original question we have the continents and the frequency counts, so generally frequency will go on the y-axis and the continents as the bars across the x-axis. In true Blue Peter tradition, here's one I prepared earlier. So from my diagram you can see we have concerts as our title, frequency as our y-axis label and a scale that makes the most of the paper that we've been given. Across the bottom you have continents as the x-axis label and the bars labelled Africa, Asia, Europe and so on. The bars are evenly spaced and all the same width, and they don't touch the y-axis. The bars also go up to the frequency from our original set of data. This is how you get all 4 marks. Question 3b asks us, what fraction of the concerts were in South America for 2 marks? And we have to give our answer in its simplest form. So South America was a count of 5. So that's 5 out of the total of 20. So now, back to our basics, we need to simplify 5 over 20. Well, 5 goes into 5 once, and it goes into 20 4 times. So, in its simplest form, the fraction of concerts was 1/4. Question 4. 80 people were asked if they owned a car. The table shows some of the information. Question 4a asks, how many men said yes? So this is quite simple. Go to the table and go from men, across, and then down from yes to get the answer 33. Nice and straightforward. Question 4b, for 3 marks, asks us to complete the table. So there are 4 gaps in the table. Again, take no chances and use your calculator. So here we have 18 plus 33 to give us our total for yes. So 18 plus 33 equals 51. Here we have 18 plus something equals 35. Well, to find the something, it's 35 minus 18, which is 17. So 17 women said no. The total of the no's then is 17 plus 12 to give us 29. And then just to prove that it all adds up, 51 plus 29 does give us our 80. There's only one more to complete, 33 plus 12 to give us this number here. So 33 plus 12 into your calculator gives us 45. And as a final check, 35 plus 45 should equal the 80 that we have. And that's how to complete the table. Question 5. A bag has 12 counters. They are pink, white, green or yellow. One counter is taken from the bag. A new counter is then added to the bag. The mode is now yellow. So really it's a question on modes, and modes are all about having the highest frequency. So let's look at each of our counters. First of all, we need to write down each of our counters by colour. So we've got pink, white, green and yellow, and we need to do a frequency count of each. So there's 1, 2, 3, 4 pink, 1, 2 white, 1, 2, 3 green and 1, 2, 3 yellow. Now, at the moment, pink is the mode. It has the highest frequency. And what we've got to do is make yellow the new mode. So in order to do this, we need to reduce the number of pinks and increase the number of yellows. Otherwise, if we increase the number of yellows by 1, it would be 4, and it would be equal mode with the pink. It would be bimodal. So the counter that we need to take away needs to be a pink, and the counter that we add must be the yellow to make it the clear mode. Question 6. A data logging machine counts people entering and leaving a museum. So here we have a table of data showing people coming and going from a museum at various times. The museum opens at 7 AM. Show that there were 24 people in the museum at 8 AM. So what you need to do is show them that you understand that 30 people came in and 6 people left to leave you with the 24. Part B, slightly more complicated for 2 marks. How many people were in the museum at 11 AM? So here you need to add everybody that's entering and then take away everybody that left to find out who is there at 11 AM. So, just like I'm doing now, enter the information into your calculator. So everybody entering means I need to add up all of the numbers for those that were entering. So 30 plus 21 plus 75 plus 40 into my calculator gives me a total of 166 people who entered the the museum. Then we need to add up everybody that left. So 6 plus 25 plus 70 plus 38 gives me, on my calculator, 139. So now, to work out how many people are left in the museum, 166 minus the 139 means there are 27 people left. And that's worth 2 marks. Question 7. Emma worked for 12 weeks. Here's a stem and leaf diagram showing the number of sales she made each week. So the key tells us that 2 bar 0 is the number 20. Underneath, there's a table which tells us each week she could earn a bonus of 15 or 50 pounds, depending on the number of sales she's had in a particular week. So any sales under £25, she doesn't make anything. Between £25 and £30 she makes £15 bonus, and then over 30 sales she makes £50 bonus. And they're asking us to calculate her total bonus for the 12 weeks. So anything under 25 we can discard because there's no bonus. So really this is the difference between 24 and 26. So none of these weeks actually earn her a bonus. So now we have to break the bonus down into the 2 areas. So between 25 and 30 she gets £50. So here we've got 26, 27, 29 and 29. So she had 4 weeks at a £15 bonus. And then she had 1 week where she had 31 sales, so she had 1 week at £50 bonus. And now we just need to work out her total bonuses. Again, take no chances and use a calculator. 4 times 15 is £60. The one at £50 is just the 50. Using your calculator, add 60 and 50 to get £110 as her bonus. Question 8 is about a reporter who asked people if they agreed with government policy. 1/3 said yes, 2/5 said no, and the rest said that they didn't know. And it's asking us to complete the pie chart for 3 marks. Okay? So now remembering the most important thing about pie charts is the fact that it's to do with the number 360. So if we look at the people who said yes, and there were 1/3, if we divide 360 by 3 to give us our 1/3, it means that the angle for the yes here should be 120 degrees. And that looks pretty good. What we're being asked to do is to plot the other 2. Now really in effect it's asking us to plot one angle because whatever left will be the don't knows. So let's have a look at the nose. So if we look at the nose, we have 2/5 of 360. Now when we do fractions of an amount, the quickest way to do it is 360, divide it by 5 first, do this on your calculator, and you will end up with 72. Then, because our numerator is 2, to get our 2/5, because 72 represents 1/5, multiply it by 2, it tells us the angle we need to draw is 144 degrees. And that will represent our no. Now this is the tricky bit, doing it with the protractor. So we need to take our protractor and put the centre of our protractor on our pie chart. We need to spin the protractor round and put the baseline in line with the baseline that we have for our yes vote. Just like this. Okay? And then using the 0 that we have here on this side with our baseline, we need to go round and plot 144 degrees. So we're going all the way round past 90 plus 100, and we need to put a marker here at 144 degrees. So just about there is our mark. We can remove our protractor. In fact, we'll just shrink it down. And then draw a straight line from the centre through our marker for 144 degrees and annotate our pie chart. There we go. So what I would be tempted to do is to draw in the angle 144 degrees to show the examiner I've measured it, and put in the no vote there. Now what's left is the don't knows. So write in don't know, and if you want to, you can write in the angle for the don't knows. Now, knowing that a circle always adds up to 360 degrees, you just need to take away 120 and the 144. Doing that on your calculator will tell you end up with 96 degrees. So this angle here is 96 degrees, and that looks about right as well. Okay, question 9 looks like it's all about a scatter graph. So a secretary types letters and answers the telephone. The time spent on 6 days are shown on the scatter graph, and the time we have is the time on the telephone plotted against the time typing. So let's take one of our crosses, for example this one, and it's telling us she spent about 260 minutes on the telephone and roughly 75 minutes typing. Okay, and that's how we plot the data, one set of data against the other, to see if there's a relationship. So let's see what they're asking us. They're telling us that the table shows the time spent for the next 4 days. Time on the telephone 275 minutes, time typing 125 minutes, and so on. So basically it's asking us to plot these additional times onto the scatter graph. So what we need to do is to plot the first point. Time on the telephone is 275, so we need to be looking up this line, and then we're going to plot it against 125 minutes, which is that one there. So we take our cross and we plot it, always plotting crosses, from 175 across to 125, roughly there. Same for the second one, 150 on the x-axis, so we go along to 150, and up to 190 on the y-axis. So 150 roughly here, 200 roughly there. The third point, 125 on the telephone, so 125 on the telephone, and then up to 225 on typing, roughly there. And then the final point, you plot 180 on the telephone, so take the 100 across, 180 roughly here, and go up to 180 on typing, so roughly there. So they're the 4 points, very roughly, that they want us to plot on our scatter graph. So we're adding to the data to see if there's a relationship. It's then asking us to draw a line of best fit. Well, a line of best fit is a line that goes to as close to all of those data points as possible. So we need to draw a straight line and make sure it covers as many of the points as we can. So let's give that a go. We start our line in the top left and move it down to the top right. I'm going to adjust it slightly, so this is what you would do with your ruler. I'm going to adjust it slightly, I don't like where it goes. And adjust it slightly at the bottom, and I'd say that's about it. So my line of best fit goes as close to all of the crosses as I can get it. Not through any particular cross, okay, it doesn't have to go through any cross, it certainly doesn't go through 0 here, and we're looking at negative correlation, okay. So that's question 9b for 1 mark. So question 9c, it always happens, is that they want to look at if she spends 200 minutes on the telephone, using our line of best fit, how much time do we think she would spend typing on that day? So we need to go to the 200 on the telephone and draw a line from 200 up until it hits our line of best fit. From there, we need to go horizontally across and read off how much time she spends on typing. So from what we've got here, I would say 125, 130, 140 minutes. when she's on the telephone for 200. So 100, 140 minutes. Question 10. There's some information here about tourism in 2012 and the number of tourists and how much each of those sets of tourists spent. It's asking us in question 10a how many more tourists visited France and Spain. So can we read the table and pull out the number of tourists in France and from France and Spain? Well, France, there were 83 million tourists, and we take away the 57.7 million tourists from Spain. Now do exactly what I'm doing, enter it on a calculator. 83 minus 57.7 equals 25.3 million tourists is the difference. Question 10b. 21% of the total spent by the tourists in the USA was by Canadians. So we need to look in the total spent column here. Okay, so we need to find out what 21% of, and then the amount spent by Canadians in the USA. So it's 21% of the USA spend, 126,200. Now if you're going to enter this on the calculator, the best way to do it is a fraction. 21 divided by 100 represents our 21%, and then multiply it by 126,200. So 21 divided by 100 multiplied by 126,200 equals, and the number I get is 26,502 million. And that's all they're after. So good use of a calculator there. Question 10c. In the UK, the total spent by tourists was 36,600 million. There were 29.3 million tourists. Work out the average spend per tourist in the UK and give your answer to the nearest $10. So what we need to do here is make sure that we're dealing with the same amounts, okay? So in the UK, the total spent by tourists was 36,600, and that's in millions, okay? Now there were 29.3 million tourists. So now if we divide it by 29.3, because again that's in millions, we don't have to put all the zeros in because they would just end up cancelling each other out, and we enter that into our calculator, we end up with 36,123 divided by 29.3 equals. So the number on the calculator is $1,249.146. Not that they're asking for this value. What they are asking for is to the nearest $10. So we've got $1,249, rounding it up, $1,250 was the average spent by tourists in the UK. Question 11. An outdoor centre has activities for children, and it's got archery, walking and sailing, and it's represented on a bar chart with frequency going up the y-axis and the days Saturday and Sunday across the x-axis. Now, question 11a tells us that adults help with walking in a ratio, and that ratio is adults to children 1:5. So we have, for every adult, they can take 5 children. It tells us that 3 adults can help with the walk on Saturday. So if we multiply the adults by 3, we have to do the same for the children. So the maximum number of children 3 adults can look after is 15 children. When we go to Saturday and look at walking, which is the centre of the 3 bars, it tells us that 20 children want to walk. However, we only have 3 adults. Therefore, no, we do not have enough, And what you'll need to do is write an explanation of why, because 20 children want to walk on Saturday and we only have 3 adults to look after them. And 3 adults can only look after 15 children. Okay, question 11b. A group of people go sailing in the ratio, so it's the number of adults to children, so adults to children is 1 to 2. Okay? What is the fraction of the group that are adults? Okay? Now here it's asking you, do you understand the relationship between ratios and fractions? And this is something we covered in week 4. Okay, it's one of our basics. If we have 1 adult for every 2 children, we have 3 parts. And if we have 3 parts, the adults represent 1/3 and the children 2/3. So the fraction of the group that are adults is 1/3. So when you have a ratio of 1 to 2, do you understand that the adults is 1/3 and that the children is 2/3? And that's 1 mark. And then 11c. On the Sunday, all the children do the activities they want. Work out the total number of adults needed for the Sunday. Let's have a look at each of our activities on the Sunday. So, for archery, which is our first column, there are 12 children that want to do it. If we look at walking on the Sunday, we can see there are 30 children that want to walk. So looking at sailing, which is our third column along, we can see that 16 children want to go sailing. Now all we need to do is use our ratio format to work out how many adults we need for each of the activities. Now we know how many children there are. So let's go along and see. So let's start with the archery. Adults to children has a ratio of 1 to 3. And we know there are 12 children that want to do archery. So we've multiplied 3 by 4 to get our 12 children. We need to do the same to the adults. So we need 4 adults to take the archery. Let's do the same for walking. Adults to children is the ratio of 1 to 5. And we know we have 30 children that want to do it, so we've multiplied that by 6, and we have to do the same on the other side of our ratio. So we need 6 adults to take the children walking. Finally, for sailing, adults to children, we have a ratio of 1 to 2, and there are 16 children who want to go sailing. Therefore, we've multiplied it by 8, and we have to do the same on the other side. So we need 8 adults to take them sailing. To get our answer, we need to add our 6, our 4 and our 8, and that gives us 18 adults in total. Question 12. In a game, a team can score 2 points for a win, 1 point for a draw and 0 points for a loss. A team plays 4 games. There are 6 combinations of results that score at least 5 points. Complete the table below. So it's already giving us 4 wins, which at 2 points is a total score of 8, and 3 wins and 1 draw and no losses, which is a total score of 7. So let's continue with the 3s then. We can have 3 wins, no draws and a loss, so 3 times 2 means we have a total of 6 points. Now we're into 2 wins, because there's no more combinations of 3. So if I win 2 games, and I draw 2 games, and I don't lose any, I have 4 points for the wins, 2 points for the draw, so again, I have 6 points. Let's say we win 2 games, we draw 1, and we lose 1. Here we have 4 points for the wins, 1 point for the draw, which gives us 5 points. Now, if we go to 4 points for the win, we can't have any losses. So we need to go down to 1 win and then 3 draws. So 1 win is 2 points, 3 draws gives us our final combination that gives us 5 points. So completing the table is a question of knowing and understanding the number of points for a win and a draw. Question 13. 4 numbers have a mean of 10 and the median is 8. 2 of the numbers are 1 and 5. Work out the other 2 numbers. So if we have 4 numbers that have a mean of 10, we know that the total of those 4 numbers has got to be 40, because 4 times our mean gives us our total for our numbers, which is 40. We also know the median is 8. But we've only got 4 numbers, so something plus something has to have an average of 8. And it's telling us that 2 of our numbers are 1 and 5. So, through logic, 5 has to be one of the 2 numbers that makes up this median of 8. So, this number and this number have to have a median of 8. If that's an average because we have 4 numbers, 8 times 2 tells us that the 2 numbers need to add up to 16. Well, if 5 is one of the numbers, the other number has to be 11, because 5 plus 11 gives me my 16, and then when I divide it by 2, it gives me my median of 8. The only other number we need to work out is the final number. Well, we know the total is 40, and we need to take away the 3 numbers that we have already. So 11 plus 5 plus 1 is 17. Take 17 from 40 and you end up with 23 as your final number. So the missing numbers are 11 and 23. Now for the final question. Jess wants to know the number of people who live in her street and she carries out a survey. Which 2 words describe the data that she collects? Circle your answers. So the fact that she carries out the survey means that the data is primary. The type of data she's collecting is people. So we know you don't get half a person or a quarter of a person or a third of a person, so the information must be discrete. Also remembering that the other option of continuous data applies to things like time, temperature, length and weight. So the 2 correct answers are primary and discrete. And this is what you get at the end of the exam paper, end of questions. If you have any spare time and you get to this point, my strong recommendation is you go back through the paper and check your questions, especially those that you struggled with. Certainly you should not have any questions that are unanswered, otherwise you're throwing marks away. This has been an Archie the Pooch production. I hope you've enjoyed it. Please join us again when we do the Unit 3 practice paper.